Hi, this is Mrs. Lee from Todd Beamer High School, and today we are going to be focusing on this right here, Appendix B. Let me see if I could get that. Yep, Appendix B, getting ready for Algebra 1 and Algebra 2. So these are the skills that you need going into Algebra 1 and Algebra 2 that will, if you know these, will help you. So good job. I'm glad you're here. And today, so I'm not sure what page this is on, but find it. Look for it. This is Activity 1, Number Sense Exponents. So if you look here, we have something with that little number right there, which we call a power or an exponent. You may have heard it as an exponent. You know, it's the E part of PEMDAS, right? So P parentheses E exponents, that's that one. All right, so what is exponents? What are exponents, right? So if you notice right here, let's choose this color. So we have 3 times 3 times 3 times 3 times 3. If we want to do this 5 times, another way to do that, because that's kind of long, is just go 3 to the 5th power. And you can use your calculator, you can use your fingers to, 3 times 3, 9, 9 times 3. Because a lot of people think plus and say 6. No, the 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, 81 times 3, 243, right? You can check for me on the calculator, right? And so on your calculator, it would look something to the effect of like, oops, writing with a highlighter, probably don't want to do that. So like x to the y, you'll see something like this, or you may see like a caret, and either one. It's usually one of those two forms, right, in your calculator. All right, so if you look at this, yeah, so this would be 243. And so if you take a look at this, there is a pattern on there, and but you can do that on your own. We're gonna go over some of these rules in a more conceptual way. Hopefully that'll help you remember them, because for me, you look down here with the tables and all this product of powers, quotient of element. So if I understood it, then I could actually just apply it just by applying what I know. Okay, so are you ready? If we take 3, we'll just use the base 3. And FYI, so this 3 is the base, the big 3, the regular 3 that we see. And this little superscript here, again, we call that our exponent, just like that. So base exponent. So if you look at this right here, if we go 3 to the, let's say, 4th power, and then multiply that by 3 to the 2nd power, right? What does that mean? What does that equal to? And we're going to keep all of our answers in powers, okay? We'll just keep it in what we call exponential form. So if we think about it in expanded form, this just means 3 times 3 times 3 times 3, right? Because there's 4 3s that we're multiplying. So 3 to the 4th power. So it's like a special type of multiplying, if you want to think about it like that. Now let's take a look at this 3 to the 2nd. Oops, just kidding. It won't let me change. Never mind. I was going to see if I can change the number or the color, but I'll just write over it. Okay, so that's 3 squared. So times that by 3 times 3, because this is 3 squared, which means 3 times 3. And if you now look at it, how many 3s are we actually multiplying now? Like, well, there's 4 here plus 2 more, so that's actually 3 to the 6th power, right? And maybe you can see the pattern right away, because we all have math brains. So if you take a look at that, do you see a pattern? Okay, I'm not going to say it yet. So maybe you can formulate your own theories on that. So we go 3 to the 3rd power, say, times that by 3 to the 10th power. And I keep on not using different colors. I'm going to just change that right now. So 3 to the 10th power. And oh, this is going to be fun. So if you're ready for this, so 3 to the 3rd power, how many 3s are we multiplying? Well, 1 times 1. So 3 times 3 times 3. Okay. And then we're also multiplying that by 3 to the 10th power. So how many 3s are we multiplying? 3 times 3 times. So how many of these do we have to do? Like 10 of them. I'm just writing 3s without even looking at it. 1, 2, 3, 4, 5, 6, 7, 8, 9, one more, 10. Okay, now how many 3s are we actually multiplying when we do this? That's actually, let me get this still over here. So that's 3 3s plus this 10 more. So that's actually 13 3s. So it's 3 to the 13th power. Do you see the pattern here? Do you see Like, is there a shortcut way? Like, do we have to write this out like this all the time? I wish you could tell me. But if you were thinking there's got to be a better way, then that's your math brain working, right? And so if you're like, well, can we just add these exponents? I'd be like, well, yeah, that makes sense, because this 3 right here is talking about how many you got, like how many we got, 1, 2, 3, 3 threes here, right? And this 10 represents how many threes we got here, all the way up to 10. So altogether we have like 13 threes. You see what I'm saying? So yeah, we can just add the exponents. So if I were to say, well, what would this be? 3 to the 14th power times 3 to the 16th power. How many? So here, if you can imagine in your brain, close your eyes and imagine, how many threes would there be multiplying? Be like 14 plus another 16 that we're multiplying. So how many altogether would that be? We're like, oh, well, that would be 3. So we're not multiplying any other number except for 3, right? And how many threes do we have? So that would be 30, right? So you see what I'm saying? So it's just literally the 14 plus 16, and that gives us 30. Okay, so 3 to the 30th power. This 3 is not going to change, because what are we actually multiplying? We're multiplying 3s. So yeah, this base never changes when we're doing stuff like this. All right, so that's where you go. And if you want to figure out what 3 to the 30th power is, your calculator probably won't be able to handle it. It'll go into like scientific notation. It'll do like an E thing. Anyways, yeah, scientific notation, that's for a different session. That's the one. You could always look it up and see what that's all about. But yes, but in exponential form, this is what it would be, 3 to the 30th power. All right, so that's okay. So far so good. Okay, so when we multiply the bases, it looks like we are adding those exponents. Okay, and then let's see here. If we are going to, oh, and questions, do you need to copy all this down? No, this is just for you. If it helps you to copy it down, then well, sure, why not? But if not, then don't. All right, but they do say that if you write it down and you hear it, and then you try to do it by yourself, your retention will be much better. Just saying. All right, so then let's try this. What if we, instead of multiplying, we're dividing, right? And so we're going to go 3 to the 4th power, divide that by 3 to the, actually, let's make this slightly bigger to make it more interesting. Okay, 3 to the 6th power over 3 to the 4th power. Okay, so what does that mean? Okay, I always like to write this out. So I really, all throughout high school, I did not memorize. Even now, I don't memorize these, right? I just think about what would it be like if I were to actually, like, what does this 3 to the 3rd power mean? Oh, 3 times 3 times 3. And if I multiply with 3 to the 10th power, like I literally like try and write it, I'm going, oh yeah, this is what it means. And it applies to all of exponents. Okay, so here we go. 3 to the 6th power. What does that mean? We're multiplying 3 how many times? I certainly hope you said 6. And there's 6 right there. And then we're going to divide that by 3 to the 4th power, which means that's how many 3s? I think you said 4, right? Did I read your mind? I'm a magician. All right, so here we go. So if you notice right here, we're just dividing, right? So if you go notice 3 divided by 3, what is 3 divided by 3? 3 divided by 3 is 1. So what we call canceling out, it's not like we're not erasing these numbers from existence. It just equals 1. And if that's the case, what's 1 times 3 times 3? It's just whatever that other thing is, right? So that's what we call canceling out, if you did not know that already. And so how many of these 3s can we cancel out? Well, we got 1 here, we got 2, 3, 4, right? So all 4 of these, four 3s on the top, 4 3s on the bottom, they cancel each other out, because what's 3 divided by 3? And again, it's 4. I'm just kidding, it's 1. You didn't hear that. Shh. This is totally not recorded. All right, and then what do we have left? We just have 3 times 3. So in essence, 3 squared. I told you we're going to just keep all of this in an exponential form. So 3 squared on top. That's all we have. That's it. On the bottom is just a 1. Can we put over 1? Yeah, you can. Like we could do like 3 squared over 1. But what's 3 squared over 1? Just 3 squared. So we don't need that. All right, so that's just gonna be 3 squared. Do you see a pattern? Do you see it? Do you see what I see? Let's just do it one more time, just in case we can test that theory. So you know that theory that you have in your brain, you're like, ooh, does that mean that we could just do this? Yeah, maybe. And so let's try again. 3 to the, let's see, 5th power over 3 squared. What would that be? Again, how many 3's on top? 5 3's on top. Because I'm running out of 3's here for room. 2 3's on the bottom. How many cancel out? So if I have 5 on top, I always do it with my fingers, right? 5 on top, 2 on the bottom. How many can I cancel out? 1, 2, right? So then what do I have left? No more 3's on the bottom, and I have 3 3's on the top, right? These all 3 3 3, right? And then so let me just do that. So 3, these all cancel out. All we have left is just 3. So 3 to the 3rd power, or 3 cubed on top. And that would be our answer. Just like that. Or if you write 27, then that's fine as well. But you can write it as an leave it as an exponential. All right. So we did multiply, we did divide. Oh, so did you get the, is there a shorter way to do this? Because what if I said, I'm going to move this right over here. So if I said 3 to the 100th power divided by 3 to the 40th power. I mean, don't make me write that many 3's. That's a lot of 3's. That's gonna be like 5 minutes, and then what, right? And then people are not gonna watch this video because it's so long, right? Because I'm spamming 3's. We don't want that. So if you imagine in your brain, we're wrote out all 100 3's on top and then 40 3's on the bottom. How many get canceled out? 100 on top, 40 on the bottom. We can cancel out 40 of them, right? That's the max. Like you can't cancel it because then we run out of 3's, right? So then how many 3's do we have left? 60 of them, right? And so if you saw the shortcut, you could just be like, well, it's 100, basically 100 minus 40, right? So we could have just done, let me just write it out here. So 3 to the 100 minus 40, which would give us that answer. Okay, so when you notice, when we multiply the bases, we add the exponents. When we divide them, what are we doing with those exponents? We subtract them. Because if you look over here, 6 minus 4 is 2, right? And 5 minus 2 is 3. This all goes back to elementary math, right? I know you all wished for that, but here it is right here before our eyes. Okay, so now what if there's a plot twist? And I'm like, well, what if we switch them? What if we go 40 on top and through? So 3 to the 40th power and 3 to the 100th power on the bottom. And then what? What do we do with that? And if you remember, right? You remember 40. So then we're going to use, if you use the same idea, right? So 40, imagine in your brain, there are 40 3's on top and then 100 3's on the bottom. We can still cancel out 40, but where are all those 3's now? They're on the bottom, right? So it's like 1 over, because there's not like there's nothing on top. Remember, they all cancel out to like 1 over 1, which is 1. So it's 1 over 3 to the 60th power. So far so good, right? To the 60th power. So then once we have, so then there's that. So it's a really, really small number because 3 to the 60th power is a really big number. But when we put it on the bottom of a fraction, there's only a 1 on top. It's like, imagine trying to cut a pizza with that many pieces and you just get 1 slice. You're like going to get crumbs pretty much, right? A little string of cheese. All right. And then, but if you remember our rule from before, we said we could just subtract them. So the other way we could have done it, we could have just done 40. So it's the top number minus the bottom number minus 100. Ooh, we get in the world of negatives, right? So it's 3 to the negative 60th power. So in essence, we're saying that this 1 over 3 to the 60th power is equal to 3 to the negative 60th power. So now we know what negative exponents do and where they came from. It is not a mystery. It's not just something that randomly math people just made up. It doesn't work like that. There's always a reason for it. And this is why, right? So what does that negative exponent mean? It just means that we have all these numbers on the bottom, like they all canceled out and the numbers were left on the bottom. That's it. Okay. So that's all that means. So how do we get out of that? Just take it to the bottom. And this is where it originally was, is 1 over 3 to the 60th power. Okay, so that's where the negative numbers come from. And then Again, it's that same rule of subtraction. That's where, so when we're dividing these bases, just subtract the exponents. That's where those negatives are coming from. All right, one more. So a lot of people think that, let's say we've been using a lot of threes today. So 3 to the 0 power, what is that? Most people will say one of two numbers. They will either say 1 or 0, and they'll go back and forth. I don't know, maybe that's you, right? So do you think it's 1 or 0? Right? So here, let me demystify that. So let's try. We're going to use the same like quotient idea. So 3 to the 4th power. Okay, so far it's pretty easy, right? Over 3 to the 4th power. Well, what's 3 to the 4th power over 3 to the 4th power? Well, remember we would have, we're taking it all the way back where we expand the whole thing, right? And we have, that's canceled out, cancel, how many, they all cancel out. What do we have left? Don't say 0, because what is this actually? What's 3 divided by 3? How many times does 3 go into 3? Once, right? So we have just, all we have left are these ones, right? So what's 1 times 1? Times 1 times 1. It's all 1, right? 1 divided by 1, 1, right? So this is actually equal to 1, which I think most people know, because if you divide some number by the same number, how many times does it go into it evenly? Once, right? So then from there, you don't see this bottom part. Close your eyes on that. We're now going to just do the same rule where we subtract them, but we also know that 3 to the 4 minus 4 is equal to, is the same thing, right? That's what we would have to do. That's the subtraction thing that we've been doing. Well, I'll give it a name soon. Okay, I won't give it a name. I'll just reveal to you the name. And so 4 minus 4, which is what? 3 to the 0 power. So that means that this 3 to the 0 power is equal to 1. And that's why it always equals 1. It would never equal 0, because when we cancel these out, would it equal 0? No, right? So there we go. So that's how that's going to work. And that's why anything to the 0 power is 1. And this is the reason why. It's not just random, just because I said so kind of thing. All right, so let's take a look at this. Oh, and by the way, did you see 3 to the negative 5th power? Right? And if you notice, there are these 1/3 and 1/3. So notice all the 3's are on the bottom instead of on the top. Okay, so let's take a look at these. It would be nice if you can try and do these yourself. So I would like pause it, like pause the video right now, then do these. Or if you're like, Miss Lee, it's the summertime, I can't, let's do it together. And I was like, okay, let's do it. I can't actually stop you. So that is up to you. I'm just glad that you're here. So let's, either way is fine. All right, so I'll give you a chance, pause. Stay very still when it's paused. I'm just kidding. All right, so here you go. So product of powers. What does product of power means? Think of product, back to your like elementary school days. Product just means multiply, right? So this just means the result of multiplication, right? I should be more exact, right? So result of multiplication, if you can read that. So when we're so basically we're multiplying the bases, right? So that's the product of powers. Powers, remember, think of exponents, right? And so if you look at this right here, that's exactly what we did here. The very first thing that we did when the purple and blue. So yep, if you notice, okay, letters are just numbers that we don't know. We just don't, they're like mystery letters. Okay. Just kidding. I take it back. They're mystery numbers. We don't know what number it is. Like, or it could be just any number, right? And we didn't want to like list all the numbers, like that's too much. Right? So we're just going to represent it with a variable, i.e. letter. Okay. So that's all we're doing. So we have A. So notice it's the same base. And notice all of these had the same base. If we had different bases, that's a little, we're talking about different things. Okay. Because it would be like saying 2 to the 5th power times 3 to the 2nd power. That's how many 2's are we multiplying there? The 5 2's, right? And then 2 3's. Well, you can't, well, and if I ask you, well, how many 3's do we have? Well, you wouldn't add them up because these are 2's and these are 3's. Do you see what I'm saying? Okay, so here we go. If they're the same bases, then what do we do with the exponents? So verbal description. If I should say, if same bases are multiplying. And if you wrote something of this gist in your workbook, that's fine. In your packet, whatever you want to call it, that's fine. So our multiple, oh my goodness, I can't spell multiplying. Help me out here. Are multiplying. Then what do we do? What do we do with the exponents? Then you just add the exponents. Just like that. Okay. Numerical example. Pick any number. Let's try 7, right? So 7 to the 4th power times 7 to the 5th power. What is that going to equal? It's going to be 7. How many 7s are we actually multiplying all together? 9 of them. So it's going to be, I'm just going to write it out completely. Normally you would not do this middle step. I'm just showing you just so that like later on you go back to it, like you don't forget it. You know what I mean? So here, if you notice, they just stop right here at m plus n, because what is m plus n? I don't know. Depends on what m is and what n is. So that's why and they're not like terms. So we're just gonna just leave it m plus n. Okay. And it's just showing you that you are just gonna add those two guys. All right. And so the quotient, same thing. So if same bases are multiplying or not multiplying, what does quotient mean? I hope you said dividing. Are dividing. Then what are we doing with the exponents? Subtract the exponents. And when I said subtract, there is a certain order to it, right? It's always top minus bottom, right? We don't go bottom minus top. Always, so as notice it's m minus n. Okay, it's not the other way around. It's always top minus bottom. If you notice our little thing here when we were actually expanding them out, that would make more sense than going to minus 5, because that's not where that's not where the 3's are left. All right. So here, let's pick another number. Shall we do 4? Let's do 4. Were you thinking of 4 as well? I don't know. So 3 to the 10th power over, I mean, did I say 3 to the 10th power? 4 to the 10th power. And divided by 4 to the, let's see, 6th power. And what do we get? It's going to be 4 to the 10 minus 6, which is equal to 4 to the 4th power. Okay, 4 times 4 times 4 times 4. Okay, that's how that goes. All right, and then the negative power, we've talked about this. So negative exponent means that it's actually supposed to be on the other side. When the other side, it means that it's supposed to be in the, if it's on the denominator side, it's going to be on the numerator, denominator, all that kind of stuff, right? So negative means base is on opposite side. That's not the official terminology for that. Don't quote me, but this is like layman's terms. Like, this is just my words. Okay, is on opposite side. When I say opposite side, I mean right here. So if it's here, a to the negative m, right? Remember all the things that were left over were on the bottom. So that would be a to the m power. But what if it was 1 over a to the n, a to the negative n, like the negative's on the bottom? Well, then it's just going to go, that means it's actually supposed to be on the other side. This is what I mean. It goes to the other side, right? So instead of being on the bottom, it actually should be on the top. So it's a to the n, just misplaced. But if you were like, wait a minute again, what does that mean? Yeah, so go back to what we're doing here, okay? Just rewind just a little bit, review that. All right, and so that's what that is. And so, for example, if we have 2 to the negative third power. And that's going to just be 1 over 2 to the third power. Notice there's no more negatives because like it's already on the other side. It's on the side it should be, right? It's on the bottom where it should be. And then for this one, let's say if it's 1 over 2 to the negative fourth power, right? What is that going to be? That's a negative, by the way. Kind of looks like a heart, but it's a negative. Right, it's on the bottom, which means it was originally supposed to be on the top, so it's just 2 to the fourth power. Okay, you got this. All right, and we'll do in the next activity, we'll do some more. We'll do some more exponents, practices, and stuff like that. So 0 power, you remember? What is the 0 power going to be? Anything to the 0 power. It has no power. Equals 1. It really doesn't matter. If you're like, ooh, what is Mrs. Lee to the 0 power? Doesn't matter, it's just 1. Okay, anything to the 0 power is 1. All right, so here we go. So a to the 0 power is 1. So if you do any numbers, so if we do like 2, 6, 4, 3, 9, 5 to the 0 power, like I told you, it really doesn't matter. What is that going to be? 1. Please don't say 0. Don't tell your teacher 0. That's like not good. It's bad days right there. All right, so power of a power. I like to say power to a power because what are you going to have? You're going to have a power and you're going to take that to another power, right? So it's like an exponent with an exponent. So here's our exponent is to an exponent. And what are we doing with that? Right? And a brief explanation of that is, well, what if we take it? So we'll do our example here. So it'll be like 4 to the third power. And we're going to then do that to the 5th power. So 4 cubed to the 5th power. What does that mean? So it just means that it's going to be 4 cubed. How many times are we going to do that? Times it 5 times. Whatever's inside the parentheses, that's what we're doing 5 times. There we go. And then now remember what we did with the product of powers? Like, so how many 4s do we have here? 3. How many do we have here? 3. 3, 3, 3, 3. So we actually have 5 groups of 3s. 5 groups of 3 4s. Does that make it confusing? But yeah, so that's actually going to be how many 4s do we have? We actually have 15 of them, right? Because there's 3 of them here. And this one is another 3 and another 3 and another 3. And do you see what I'm saying? So yeah, that is going to be 15. Do you see that the trick here? Though, like the easier way to do this, because this is kind of long. Yeah, you're just going to multiply those because I like to circle them. You just multiply them. So you are going to be multiplying because it's 5 groups of 3 4s. Okay, 3 stuff. Okay, so that's why it's going to be the 5 groups of 3. That's, remember, go back to your elementary school days. That's what that is. All right. So again, we'll put that in here. So 4 to the 3rd power to the 5th power is just equal to 4 to the 5th. Oh, 3 times 5, which is equal to 4 to the 15. Okay, again, this middle step you don't need to do. It's just when I always like for notes, like to go back to it, like, oh yeah, like do it literally step by step. So when I look back, I'm like, how did I get 15? Then I'll like make up my own rule that is completely irrelevant. Yeah, I don't know if you do that. So if it's you have an exponent to an exponent. Oh, spelled that wrong. Multiply exponents. A lot of exponents here. 3 that I wrote, I think. So power of a product. So if you look at this guy right here, it's the same idea, right? Some may think, oh, you can just distribute the power. Some people think of it that way. I like to think of it as it's the exact same thing as what we just did here. So if we're going to do 2 to the 3rd power times 3 to the 4th power, and we do all of that squared. So what are we doing? We're taking this, all of this, so 2 to the third power times 3 to the fourth power. And how many times do we do that? 1, 2 times. So here's 1, here's the other one. So that's twice, right? And so how many times, how many 2's do we actually have? Well, we have 3 here and we have 3 here. So how many 2's do we actually have? 2 to the 6th power, right? And same thing with the 3's. How many 3's do we actually have? 3 to the 8th power. So is there a faster way to do that instead of writing this all out? You notice 3 times 2 is 6. 4 times 2 is 8. It's basically just this. It's just yeah. So that's what it is. So that's the power of product. So here is our product, and we're taking that product to the power. Okay. And so there we go. So when we have, let's see, if the product of 2 bases are taken to a power, so you're going to multiply. We're still multiplying power with each exponent. I hope you guys can read that. Can you guys read that? All right. So if a product of 2 bases are taken to a power, so a product of 2 bases, they don't have to be the same, so I didn't write down same, are taken to an exponent. So you're going to multiply the power, this power right here, with each of these exponents. Has nothing to do with the bases, to the exponents. All right, and then we'll use this example here. So it's going to be 2 cubed times 3 to the 4th power squared. So that's going to be the same as 2 to the 3rd power times 2, and then times 3 to the 4th power times 2, i.e. that's going to be 2 to the 6th power times 3 to the 8th power. Just like that. All right, last one, power of a quotient. So what if we have it with dividing? It's the same idea, right? So it's going to be the exact same thing as this one, except if the, let's see if I can just copy it down. My light, nope, it won't let me, it won't let me copy it down. Oh well, that's just sad days right there. That's okay. So I guess I will have to write it out. So it's the same thing. So if the quotient of 2 bases are taken to a power, and then we're going to multiply. Yes, we're going to multiply the power with each exponent. Right, still the same. It's the same action. It just looks a little different. Multiply power with each exponent. Pretend that that actually spells exponent. So if we were to take a look at this one, remember, so if I'm going to use the exact same example, except now I'm going to divide them. And we're going to square that. So again, remember what this means. It just means 2 to the 3rd power over 3 to the 4th power times it by again, because it says squared. So that just means 2 times. So what do we actually get? 2 to the 6th power over 3 to the 8th power, right? Because there's eight of them, 8 3's down here, and there's 6 2's on the top. Okay, so same idea here. So 2 to the 3rd power over 3 to the 4th power squared. That's going to just be, I'm going to write this out, 2 to the 3 times 2 divided by 3 to the 4 times 2, which would be 2 to the 6 over 3 to the 8th. Okay, and please make your exponents smaller. Don't do things like this, 3 to the 8th. That just looks like 38 at this point. Don't do that. I've had people do that. Only don't do that. That's not a good idea. All right, so there we go. All right, and normally, I don't know if I would have done all of the work for you. Well, I always like showing the answers because I feel like, you know, well, what if you got it wrong and you didn't know, right? But anyways, so join me next time. So when we're gonna do some more practice on these exponents. I'll see you later. Bye.